are using a computer radio. ఒకటేనా? ఓకే ఓకేనా? Hello, good afternoon. Is it audible? Is it audible? Okay. Hello everyone, good afternoon. Is it audible? Okay. So let us go to the class. Yesterday I have started the differential equation topic, but for some of you, the two topics were completed, linear algebra and calculus. Don't worry about the completed topics. Later the topics will be arranged for you. They will arrange for linear algebra and they will arrange the separate class for calculus also. Don't worry about the completed topics. So I am taking the differential equation topic. Later you may have the other topic also. So don't worry about the completed topics. Later you will have that linear algebra separately and calculus also separately on. Now let us come to our topic, differential equation topic. Yesterday we have started the differential equation topic and we have written the subtopics of differential equation. After that we have started the first subtopic or first part, basic definitions. We have started the differential equation and the weightage of this topic is 1 to 3 marks. Also, we are dividing this topic into 3 parts. One is basic definitions, and the second part is ordinary differential equations. Third part is partial differential equations. Because I am dividing the total topic into 3 parts: ordinary differential equations, partial differential equations, and basic definitions. Yesterday, we have completed the first subtopic or first part of the differential equation, basic definitions. Now, before going to start, revise the basic definitions, we'll discuss about something regarding the marks on it. The weightage of this topic is 1 to 3 marks in the GATE examination, as well as the IES examination also. Even though the weightage is 1 to 3, sometimes you may get more than 3 marks also. Sometimes you may get less than 3 marks also. Not always exactly 3 marks or 2 marks or 1 mark. It may vary. In one topic, in one topic differential equation, if you get more marks, in other subtopics of the same mathematics, you will get less number of marks. Suppose in the differential equation, if you get less number of marks, in other topics, you will get more marks only. It may vary only. Always you may not get 3 exactly or 4 exactly or 2 exactly or 1 exactly only. It may vary only. So main weightage is 1 to 3 marks. For GATE 1 to 3 marks, for IES also 1 to 4 marks. 1 to 4 marks. For GATE 1 to 3 marks. But for EC branch, in the year 2017, 2018, in these 2 years, 4 marks were given. In the year 2017, 2018, 4 marks were given only from the differential equation topic for EC branch. In the recent year 2020 GATE examination, for EC branch, 1 plus 2, totally 3 marks were given from the differential equation topic. For instrumentation branch, only 1 2 marks question was given. 1 2 marks question was given only. That is only 2 marks only for instrumentation in the year 2020. For EC branch in the year 2020, 1 plus 2, totally 3 marks were given. Whereas in the year 2017, 2018 for EC branch, 4 marks were given from the differential equation topic in the 2 consecutive years. 1920, only 3 marks on it. So sometimes you may get more than 3, sometimes you may get less than 3 also. Sometimes you may get only 1 mark question also from differential equation. If you get less number of marks in differential equation, you will get more marks in another subtopics of same mathematics part. Right? Now for gate examination, we have the 28 years previous question papers on. How many years? For gate examination, we have the 28 years previous years question papers on. Whereas IES, just 4 years papers. Only 4 years papers. For gate examination, we have the 28 years question papers and IES only 4 years only. So if you observe all the 28 years question papers, we can say that so-and-so topics are important and so-and-so methods are important on. The one of the advantage of differential equation is we can choose answer by verification on. We can choose answer by verification. That is one of the advantage of the differential equation topic. But always it may not be possible. That depends on the question. Depending on the question, we can choose answer by verification. Depending on the problem, we can do the problem by method also. So always verification is not possible, but if it is possible to choose answer by verification, we can choose answer by verification. That is possible for a differential equation. But most of the problems can be solved by verification method in the differential equation. So in the gate examination, you need not to prepare all the methods. First, according to syllabus, we'll discuss all the methods. Later, I will tell you whatever the important methods are. Next, regarding gate examination, for EC and instrumentation, the first 2 topics are very, very important. For EC and instrumentation branch, regarding gate, we have these 2 important. Basic definitions and ordinary differential equations on. Only for EC branch, till now, there is no gate question on partial differential equation. In the gate examination, till now, there is no gate question from the partial differential equation. Till now, there is no gate question only. That is a partial differential equation, not much important in the gate examination for EC branch. When you come to the instrumentation branch, if you observe the 28 years papers, for instrumentation, there is only 1 gate question on partial differential equation. There is only 1 gate question on partial differential equation. Otherwise, no questions. So if you observe all these papers, we can say so-and-so important. So out of 3 subtopics or 3 parts of the differential equation, the first 2 are very, very important for gate examination. Basic definitions and ordinary differential equation. Partial differential equation not much important because there is no gate question from partial differential equation for EC branch. For instrumentation, only 1 gate question. Next, coming to the IES. For IES, till now we have only 4 years previous question papers only. That is 2020, 2019, 2018, 2017. In the year 2020, 1 question was given from differential equation topic, that is 2 marks. And 2019 also 1 question is given from differential equation topic. 2008, in the year 2018, there is no question from differential equation topic. So no question from differential equation topic in the year 18. In the year 17, 2 plus 2, totally 4 marks were given from differential equation. In the IES examination, each question carries 2 marks only. So 1 question means 2 marks, 1 question 2 marks. But in the year 2017, 2 questions were given. Out of 2 questions, 1 question is from partial differential equation and 1 question is from ordinary differential equation. Out of these 4 years, 2017 to 2020. 2017 to 2020. We have only 4 previous questions on differential equation for IES examination. Out of 4 questions, 2 questions from ordinary differential equation, 2 questions from partial differential equation. So for IES, you have to prepare all the 3 parts of the differential equation: basic definitions, ordinary differential equations, and partial differential equations. But for GATE examination, first 2 are very, very important. Last is not much important. For IES, all. While discussing the differential equation topic, whenever I say important, wherever I say important, that important is only for GATE, not for IES. Whenever I say important, that is only for GATE, not for IES. IES means you have to prepare all. Because of the 4 years previous years papers, I cannot say so and so important only. But for GATE examination, I can say that so and so important only. And while discussing also, I'll tell the important only. At the end of the topic also, once again, I'll tell the important. Don't worry about that one. So differential equation, simple topic, but for this differential equation, you require all the derivative formulae and integral formulae. You must remember the derivative formulae, integral formulae. These 2 are very, very important. Not only for mathematics, these 2 formulae are important. These 2 means differential quotients formulae, integral formulae. These formulae are important for your core subjects also, not only for this mathematics part. Right? I think you are following on. Are you following on? So this is about topic regarding marks and this. But in the year 2000, that is up to last year, 2020, only 2 types of questions were there. One is fill in the blank question, that is numerical answer type. Other one is multiple choice questions. For question, 4 options will be given and you have to choose only 1 question. But in the next year, that is for coming year, 2021, 1 more type of questions were introduced, that is multiple selection questions. That means multiple correct answer questions, just like IIT JEE. For questions, 4 options will be given. Out of 4 options, 1 answer may be correct, or 2 answers may be correct, or 3 answers may be correct, or 4 options may be correct. Answers may be your options. So more than 1 option also will be given. In such cases, verification doesn't work. So that is why you have to learn all the methods on. So first we'll discuss about all the methods, and then I will tell what are the important topics. So this is very simple topic, but you have to remember only differentiation and integration formula. That is very, very important. Without that, we can't do anything. Except linear algebra topic, all the differentiation integration formulae are required for all other subtopics of mathematics. For linear algebra, not required. Differentiation integration formula. Right. Now let us go to the previous day class. Just I revise what we have discussed in the last class. Yesterday we have started the basic definitions part, or first part of the differential equation. In that we have seen the 8 definitions. How many definitions? 8 definitions. I'll tell all the names one by one. The first definition is differential equation. The first definition, differential equation. Second definition is types of differential equations. Third definition is order of a differential equation. Fourth definition is degree of a differential equation. And the fifth definition is linear differential equation. Sixth is non-linear differential equation. Seventh one is homogeneous differential equation. And eighth one is non-homogeneous differential equation. We have discussed about all these definitions, and also we have written the examples. I've explained all these definitions through examples also, right? And one note point for all. Today, after closing the session at 4 o'clock, 4 to 4:30, I will take the doubt session. If you have any doubts in that 4 to 4:30 session, we can ask the doubts on regarding this differential equation topic today and yesterday. So 4 to 4:30, you will have a doubt session, right? If you have a doubt, you can ask. Otherwise, you can take the break. I will close the session at 2 o'clock. I will close the session at 4 o'clock. After 4, you will have a break. But in the break time, I will take the half an hour doubt session only. So yesterday we have started the differential equation topic. In that, the first part is basic definitions. In the first part, the first definition is differential equation. I revise all the previous day class definitions. If any equation contains derivatives or differentials, then such an equation is called differential equation. If any equation contains derivatives or differentials, then such an equation is called differential equation. But I told you that there are two types of derivatives. One is ordinary derivative, other one is partial derivative. There are two types of derivatives, ordinary and partial. For a function of one independent variable, the derivative is written as dy by dx. Again, its derivative is d square y by dx square. For a function of one independent variable, derivatives are written as like this, first order, second order, and so on like this. Here, in this relation, y equal to f of x, x is the independent variable and y is the dependent variable. We always write the derivative of dependent variable with respect to independent variable. That is like this. D of dependent variable divided by d of independent variable. We always write the derivative of dependent variable with respect to independent variable. Suppose if it is x equal to f of y, then we write the derivative as dx by dy, because here x is dependent variable, y is independent variable. Again, it's a derivative d square x by dy square, and so on. Similarly, for a function of more than one independent variable, z equal to f of x, y, the derivative is written as dou z by dou x. For ordinary, d for Delhi, d. For partial, dou, like this. We pronounce this as dou z by dou x. And some people may read this as, pronounce this as del z by del x, like this only. But here I pronounce this as dou z by dou x. Dou, d, dou. For ordinary derivatives, d. For partial derivatives, dou. It is only difference. So for this two variable function, the partial derivatives are written as dou z by dou x, dou z by dou y. And the second order derivatives are dou square z by dou x square, dou square z by dou x, dou y, dou square z by dou y square, and so on like this. So more than one variable function, the derivatives are partial derivatives. For one variable function, ordinary derivatives only. So we have two types of derivatives. One is ordinary, other one is partial derivative. Right? So we have seen all this yesterday. That's why I'm repeating this. So if a differential equation contains derivatives like this, that may be ordinary or partial, or sometimes the different equation may contain like this dy only, dx only. Dy means differential of y. Dx means differential of x. Here change in y, only single variable, change in x. Here dy by dx means change in one quantity y correspond to change in quantity x only. Change in y correspond to change in x only. So dy by dx. Here dy means change in only one quantity y, or change in only one variable y. Dx means change in only one quantity x, or one variable x only. So if any equation contains derivatives, that may be ordinary or partial or differentials, then such an equation is differential equation. Next. Second definition is types of differential equations. In the types of differential equation, we had two types. One is ordinary differential equation, other one is partial differential equation. If a differential equation contains only ordinary derivatives, then such an equation is ordinary differential equation. If a differential equation contains only partial derivatives, then such an equation is called partial differential equation. There are two types of derivatives, ordinary and partial. Because of the two types of derivatives, we have two types of differential equations. Next, third definition is order of a differential equation. Order of a differential equation. The order of the differential equation depends on the highest order derivative only. Suppose in the differential equation, the second order is the highest order, then order of that second order is the order of the differential equation. Next, fourth one, degree. For degree also we require the highest order derivative. After identifying the highest order derivative, then we consider its power on. The power of the derivative is the degree of the differential equation. But the condition is the power should not be fraction and should not be radical. Even the radical sign exists or fraction exists, possible to eliminate, we eliminate. Otherwise, no degree on. So for every differential equation, order is possible always, but degree may or may not possible. Next, the fifth definition is linear differential equation. The linearity of the differential equation depends on dependent variable. So there are four conditions for linear depending on dependent variable and its derivatives only. Wherever the dependent variable exists, its power should be 1 only. And wherever the derivative of dependent variable exists, its power should be 1. Whatever the order of the derivative, doesn't matter. The power of the derivative should be 1. And the product of dependent variable and its derivative should not exist. The product of dependent variable and its derivative should not exist. And the fourth condition is transcendental function. Any transcendental function exists. Any transcendental function exists. That function should be a function of constant or function of independent variable. Should not be a function of dependent variable. For example, tan function is present in the equation. For linear, tan of something, the something should not be dependent variable on it. It should be an independent variable on it. The transcendental functions means exponential, logarithmic, trigonometric, inverse trigonometric, hyperbolic, all inverse hyperbolic. All these are called transcendental functions. So the four conditions satisfied, then the equation is called linear. Otherwise, non-linear. Otherwise means any one of the four conditions fail, then that equation is called non-linear differential equation. Next, homogeneous and non-homogeneous. The homogeneous and non-homogeneous also will depend on the same dependent variable on them. Every term of a differential equation contains either a dependent variable or its derivatives. Then such a differential equation is called homogeneous. In every term, either a dependent variable or a derivative exists. Then such an equation is homogeneous, otherwise non-homogeneous. Otherwise means in any one term of the differential equation, derivative is not present or a dependent variable is not present. Then such an equation is non-homogeneous equation. So these are the 8 basic definitions on. Instead of discussing all these definitions separately in ODE and PDE, we are discussing all these at one place only because all these are same for both ODE and PDE only. Because we have directly the gate questions on these definitions. And also these are indirectly required to identify the method depending on the problem for solving the equation. right? So this is about yesterday's class. Now I'll write the some previous gate questions on these basic definitions so that you will know how the questions will come, and you can check your the basic definitions also by answering all these. So in the next page, still anybody has doubt, then you can ask 4 to 4:30 session. So I continue this class up to 4 o'clock, and 4 to 4:30 I will take the doubts session. Okay? Don't worry about this. Now I am writing the some previous gate questions on the basic definitions, and check whether you are able to answer or not based on definitions only. The first question. The differential equation 3 into d square y by dt square plus 4 into dy by dt. For dy by dt, power is 3 plus y square plus 2 equal to t has option A, degree equal to 2, comma, order equal to 1. Option B, degree equal to 1, order equal to 2. Option C, degree equal to 4, order equal to 3. Option D, degree equal to 2, order equal to 3. Don't take this screenshot. Write down this question. The total notes will be uploaded. That is, PDF will be uploaded. Suppose if you have not received yesterday's PDF and anybody has received, no problem. If you have not received, then you will get it today at the end of the class. At the end of the class means at the end of the day. So most of them are saying that answer B. Now let us check whether it is correct or not. According to this question, it was asked to find the order and degree of the differential equation. Order and degree of the differential equation. It is an ordinary differential equation. To write the order and degree, to write the both order and degree, we require the highest order derivative only. In this differential equation, there are two order derivatives. First order derivative, second order derivative. Second order derivative is the highest order derivative only. Second order derivative is the highest order derivative. So order of this highest order is the order. Because second order is the highest order, order of the differential equation is 2. Order of the differential equation is 2 only. Suppose in only one option order is given as 2, then that is second order equation directly. And that answer will be correct only. That is a B is the answer. Next we check the degree only. To find the degree also, first you have to consider the highest order derivative. Here the highest order derivative is second order derivative. After that we observe its power. The power of this second order derivative is 1. So degree will be 1 only. It is a second order first degree differential equation. That is why answer B is correct. It is a EC gate question. One more question. Next, we go to next question. Question number 2. Which one of the following is a linear non-homogeneous differential equation, comma, where x and y are the independent variable and dependent variable. Respectively. Option A, dy by dx plus xy equal to e power minus x. Option B, dy by dx plus xy equal to 0. Option C, dy by dx plus xy equal to e power minus y. Option D, dy by dx plus e power minus y equal to 0. It is a GATE question of EC branch. It's a 1 mark question. I repeat the question. Which one of the following is a linear non-homogeneous differential equation where x and y are independent and dependent variables respectively? Now tell me the answer. Completed? Okay, now we'll check one by one option. According to question, it was asked to find the both linear and non-homogeneous only. It was asked to find the linear and non-homogeneous. So first we check the linear condition. After that, we check the non-homogeneous condition. Both satisfied, that will be our answer. Let us start with the first option. The first option, first we check the linear condition. For linear, there are 4 conditions. Wherever the derivative exists of any order, the power of the derivative should be 1. Wherever the dependent variable exists, its power should be 1. Wherever the transcendental function exists, it should be a function of constant or independent variable. In every option, the first order derivative is present, dy by dx. Because of dy by dx, y is the dependent variable, x is the independent variable, that is already mentioned. So in the first option, the power of the derivative is 1. The power of the dependent variable is 1. Exponential function is present. It is a transcendental function of independent variable x only. So all the conditions of linearity are satisfied. So the first option is linear. First we check the linear for every option and then we choose the non-homogeneous. The second option, the power of the derivative is 1, power of the dependent variable is 1. There is no product of these two. So it is a linear. A and B are linear. In the third option, transcendental function, exponential function is a function of dependent variable y. Because of this term, it is non-linear, eliminated. The last option, it is a transcendental function of dependent variable. So because of this, the equation is non-linear. C and D are non-linear. We require the linear and also non-homogeneous. The first 2 options are linear. Next, we check anyone is non-homogeneous or not. According to definition of homogeneous, non-homogeneous, again we check the dependent variable is present or not, derivative is present or not in every term only. In every term of the differential equation, derivative or its derivative exists or a dependent variable exists, that is homogeneous, otherwise non-homogeneous. In the first option, first term is containing the derivative, second term is containing the dependent variable. On right hand side, there is no dependent variable. Why? There is no derivative. Because of this term, the equation is non-homogeneous. So the first option is correct. In the second option, every term is containing with a dependent variable derivative. That is why it is homogeneous. Second option is homogeneous. First option is non-homogeneous. So the very first option is correct because it is both linear and non-homogeneous. So these are the gate questions. Here I wrote only 2 questions, but there are many questions only. I am not writing all the questions. From these 2 questions, we can say that in easy we can solve these 2 problems like this only, even if we get questions on basic definitions. So with this, the first part, basic definitions, is completed. Now we are going to start the second part of the differential equation. Second part is ordinary differential equations. Now, second part, ordinary differential equations. In short form, O dot D dot E. Out of 3 parts, basic definitions, ordinary differential equation, partial differential equation, the first 2 parts are important for gate point of view. So out of 2 important parts, first part is completed. Next we are going to start the second part, ODE. In the ODE, again we have the 4 subtopics. In the ordinary differential equation, again we have the 4 subtopics. One is solution, second one is types of solution, third one is first order and first degree, and the last one is second and higher order differential equations. So first we start with the first subtopic, solution of a differential equation. Before going to start the solution of differential equation, we'll discuss about some equation. I'm taking one example here. X minus 4 equal to 0. It is one equation without derivatives. So it is not a differential equation, just algebraic equation, because it is a variable with a variable x. Now tell me the value of x for which this equation satisfies. If I ask the question, the value of x for this, then we can say that x equal to 4. If substitute x equal to 4, the LHS will become 0. That will be same as the RHS. So this equation satisfies with x equal to 4. Therefore, x equal to 4 is a solution of differential equation. Or other way, to check whether the equation satisfies or not with x equal to 4, we consider LHS separately, RHS separately of the equation. The LHS part of the equation is x minus 4. RHS part of the equation is 0. We substitute x equal to 4 in both LHS and RHS and we check whether they are same or not. 4 minus 4 equal to 0. Here there is no x, directly 0. So LHS is same as RHS. The equation is satisfied with x equal to 4. Therefore, x equal to 4 is a solution of the equation. So like this for differential equations also. Now I am considering one equation, y equal to e power x. here dy by dx equal to y. Y equal to e power x is free from derivatives, so it is not a differential equation. Here dy by dx equal to y, it is with the derivatives of differential equation. This is a differential equation. We check this equation satisfies with y equal to e power x or not. To check the differential equation satisfies or not with this, we consider LHS separately, RHS separately of the differential equation. LHS of the differential equation is dy by dx. RHS of the equation is y. But y equal to e power x. D by dx of e power x equal to e power x. Y equal to e power x. LHS equal to RHS. The differential equation is satisfied with this relation y equal to e power x. Therefore, y equal to e power x is a solution of a differential equation. So here solution means it is a relation between the variables x and y, or it is a relation between the independent and dependent variables satisfying the equation. Let us go to the another example. Dy by dx equal to 1. Y equal to x. When I substitute y equal to x here, that will be 1, same as the RHS. So the differential equation is satisfied with the y equal to x. Therefore, it is a solution of the equation. Or if I take another relation, y equal to x minus 4, the differential equation will satisfy with this also. It is also a solution of the equation. Y equal to x plus 7 by 3. The differential equation will satisfy with this relation also. So it is a solution. Y equal to x minus 4 by 3 power 7 by 2 power 3 by 92 power 7. Again, with this also, the equation will satisfy. So it is a solution on. Or y equal to x plus c, it is also solution. Here, this differential equation will satisfy with all these relations on. Therefore, all these relations are solutions of the differential equation. Let us go to the another example. Y double dash minus y equal to 0. This is a second order differential equation. Now I am taking some relation here. Y equal to e power x minus 4 into e power minus x. If you find the first derivative and second derivative for this, y dash equal to e power x minus plus 4 e power minus x, and y double dash equal to e power x minus 4 e power minus x. If you substitute y and y double dash in this equation will satisfy. Therefore, this is a solution of the equation. Y equal to 4 into e power x. Its first derivative equal to 4 e power x, second derivative equal to 4 into e power x. So it is also another solution of this equation. Y equal to minus 7 by 2 into e power minus x. Its first derivative equal to y equal to 7 by 2 e power minus x. Y double dash equal to minus 7 by 2 e power minus x. It is also solution of the equation. Or if we consider the y equal to a into e power x plus b into e power minus x. In the first term, first derivative same, second derivative same. The second term, first derivative is minus b e power minus, second derivative is minus plus b e power minus x. So the differential equation will satisfy with this relation also. So all these are solutions. So from all these examples, we can say that the solution of the differential equation is same as relation between the variables. Relation between the variables. So if any relation containing the one independent variable and one dependent variable satisfies the differential equation, such a relation is called solution of a differential equation. Here solution is a relation between the variables satisfying the differential equation. Now in the second example, y equal to x minus 4, y equal to x plus 7 by 3 and so on. These are the solutions. In the first example, just y equal to e power x. It is a relation between just two variables, independent variable and dependent variable, satisfying the equation. In the second example, y equal to x, y equal to x minus 4, y equal to x plus 7 by 3, and so on. In the second example, in this first one, just we have variables. In the second one, not only variables, we have constant also. Variables, constant, variables, constant, variables, constant. In these relations, we have a particular constant. Here we have a general constant. We can obtain the y equal to x from y equal to x plus c. We can write the y equal to x from y equal to x plus c for c equal to 0. We can write the y equal to x minus 4 from y equal to x plus c for c equal to minus 4. We can write the y equal to x plus 7 by 3 from y equal to x plus c for c equal to 7 by 3. So satisfying this differential equation, satisfying the differential equation dy by dx equal to 1, we can add the many solutions like this. And we can find all these solutions. We can write all these solutions from one solution y equal to x plus c only. That is why this solution y equal to x plus c solution is called general solution, complete solution only. And we can write all other solutions from this general solution for particular values of c. That is why all these are particular solutions. So solution means relation between the variables satisfying the equation. And there are two types of solutions. One is general solution, other one is particular solution. If you write every solution of differential equation from one of the solution, then such a solution is called general solution. Or other way, if any solution gives many solutions of the differential equation for particular values of c, such a solution general solution. Or the other way also we can define general solution like this. In the second example, the differential equation is dy by dx equal to 1. The order of the differential equation is 1. In this solution, y equal to x plus c, only one general constant c present only. In any solution, number of general constants is same as order of the differential equation. Such a solution is called general solution. Or the number of arbitrary constants in a solution is equal to order of the differential equation, then such a solution is called general solution. That is, if any solution generates infinitely many solutions of the differential equation. Satisfying one differential equation, we can write many solutions only. If we can write all the solutions only from one solution, such a solution is called general solution. The third example, y double dash minus y equal to 0. Y equal to a e power x plus b into e power minus x. From this y equal to a into e power x plus b into e power minus x, we can write all other solutions for particular values of a and b only. That is why this is called general solution only. This is general solution. Or if any solution generates every solution of differential equation, that solution is also general solution. Other way, the number of arbitrary constants is equal to order of the differential equation, then such a solution is called general solution. Right? This is about the solution and types of solutions. Solution is relation between the variables satisfying the equation. There are two types of solutions. One is general, other one is particular, depending on the constant, arbitrary constant or particular constant. Okay. Now I write down all the definitions. We are in second part, ODE. In the ODE, there are 4 subtopics. One is solution. Solution of a differential equation. I've written this definition. If a relation a relation containing one independent variable, in short form I dot v, and one dependent variable, in short form dv. If a relation containing one independent variable and one dependent variable satisfies the given differential equation, then such a relation is called a solution of a differential equation. It is a definition of the solution of a differential equation. Example, y equal to e power x is a solution of a differential equation. dy by dx equal to y. Example 2, y equal to a cos x plus b sin x is a solution of a differential equation y double dash plus y equal to 0. This is the first definition, solution of a differential equation. Next, the second one. Types of solutions. Types of solutions of a differential equation. So there are two types of solutions. One is general solution. In short form, we write this as G dot S. And it is also called complete solution. C dot S. General solution, complete solution. I write down the definition of this. If the number of arbitrary constants or general constants the number of arbitrary constants or general constants in a solution is equal to the order of the differential equation. If the number of arbitrary constants or general constants in a solution is equal to order of the differential equation, then such a solution such a solution is called a general solution of a differential equation. Example, y equal to x plus c is a general solution of a differential equation dy by dx equal to 1. In the solution, number of general constants is 1 and the order of the differential equation is 1. That is why it is a general solution of the differential equation. In any solution, number of arbitrary constants is same as order of the differential equation. Such a solution is general solution. Example number 2, y equal to a into e power x plus b into e power minus x is a general solution of a differential equation d square y by dx square minus y equal to 0 or y double dash minus y equal to 0. Next, second bit or second type of solution, particular solution. In short form, P dot S, particular solution. If a solution is obtained, from a general solution, the solution is obtained from a general solution for particular values, for particular values, a solution obtained from a general solution for particular values of arbitrary constants then such a solution is called a particular solution of a differential equation. The solution is obtained from general solution for particular values of arbitrary constants. Then such a solution is called particular solution of a differential equation. Example, if y equal to x plus c is a general solution of a differential equation dy by dx equal to 1, then y equal to x minus 3 by 4 is a particular solution of a differential equation dy by dx equal to 1 for c equal to minus 3 by 4. So this y equal to x minus 3 by 4 is one of the particular solution of this differential equation for c equal to minus 3 by 4. If I substitute c equal to 0, we get one solution. If I substitute c equal to 7, one solution. C equal to 9, one solution. C equal to 1000, one solution. For many values of c, we get many solutions. That is why satisfying the differential equation, we can find the infinitely many solutions. And remember one point, for a differential equation, only one general solution exists. Only one general solution exists, but infinitely many particular solutions exist. So number of particular solutions is infinite. General solution is unique. Only one general solution exists, but infinitely many particular solutions exist. Next, example number 2. If y equal to a into e power x plus b into e power minus x is a general solution of a differential equation y double dash minus y equal to 0, then y equal to minus 3 by 4 into e power x plus 7 into e power minus x is a solution. That is particular solution of a differential equation. Like this, we can write the many particular solution for many particular values of a and b only. But here it is a one of the particular solution for c equal to minus 3 by 4 and so not c, this is a, and b equal to 7. So from all this we can set solution means relation between the variables satisfying the equation. And there are two types of solutions. One is general solution, other one is particular solution. Only one general solution exists for a differential equation, and infinitely many particular solutions exist for particular values of arbitrary constants. We are in ordinary differential equation subtopic. In this, we have 4 subtopics. One is solution, other one is types of solution. Next, first order, first degree, and second higher order. So 4 subtopics are there in the second part, ODE. Out of 4 subtopics of ODE, 2 are completed. Solution, type solution is completed. These 2 are completed. Now we start the third subtopic of the ODE. The third subtopic of ODE is first order and first degree differential equation. In the ODE, in the second part ODE, there are 4 subtopics: solution, types of solution, first order and first degree differential equation, second and higher order differential equation. We have a gate questions or IES questions on first order and first degree, second and higher order only, not on solution, types of solutions. But before going to write the solution of this equation, first we should know the solution, what is the meaning of solution, and the types of solutions only. Now in this third subtopic, first order, first degree differential equation, first we write its general form, and then we'll discuss about methods of finding the solutions of the equation. So in which the first bit, general form. General form of a first order and first degree in the first order, first degree, first where its general form only. A differential equation of the form dy by dx equal to f of x comma y, or m of x comma y dx plus n of x comma y dy equal to 0, comma, where f of x comma y comma m of x comma y and n of x comma y are continuous functions comma, is called a first order and first degree differential equation, or it is a general form of the first order first degree differential equation. So we have the two general forms for first order first degree differential equation. One of the form is dy by dx equal to f of x comma y. Other form is m dx plus n dy equal to 0. The first form, dy by dx equal to f of x comma, it is derivative form. Other form is m dx plus n dy. Other form is differential form. Dx means differential of x. Dy means differential of y. Dy by dx means differential coefficient. They are derivative only. So we have two general forms of the first order first degree. One is derivative form, other one is differential form. And the condition is here functions f, m, n should be continuous functions only. That's the condition. Next, second bit. Initial value problem. Initial value problem. First, we'll discuss about this initial value problem. Later, I will write the definition. Just look at this and listen this. I'm not writing the definition first here. Later, I will write the definition. Sometimes we can write the same above differential equation in the form of like this: f of x comma y dash equal to 0. Instead of writing the differential equation dy by dx to f of x comma y or m dx plus n dy equal to 0, we can write the equation like this also: f of x y dash equal to 0. It is a first order differential equation. For this equation, if we write the solution, that may be general solution or particular solution. First, we write the general solution, and then we write the particular solution. Then we write the particular solution. The general solution, already we know the general solution definition, particular solution definition, because every solution may not be a general solution. Every solution may not be a general solution. There is some condition for general solution. In any solution, number of arbitrary constants or general constants is equal to order of the differential equation. Here we have taken the first order differential equation. Because of the first order differential equation, its general solution should contain only one arbitrary constant. Let us suppose its general form is f of x, y, c1 equal to 0. It is a general solution because one arbitrary constant c1. From general solution, we write the particular solution, but we write the particular solution from general solution for particular value of c1. So to write this particular value for c1, in the question, we will be given some value of dependent variable y at some value of independent variable x. To find the c1 value, we will be given some data like this one: y equal to something at x equal to something. In the same way, for a second order equation, f of x, y dash, y double dash equal to 0, its general solution will be in the form of f of x, y, c1, comma c2 equal to 0. From this, we write the particular solution. Because the second order equation, its general solution contains two arbitrary constants, C1, C2. To write the particular solution, we require the C1, C2 values. For obtaining the C1, C2 values, we'll be given some data like this. Y equal to something, at x equal to something. Y dash equal to something, at x equal to something. To find the two unknown constants, we require two equations. For two equations, will be given like this. Or, not always y dash. Sometimes it may be y dash equal to something and y dash equal to something at x equal to something. Like this. Or sometimes only y's will be given. Y equal to something and y equal to something at x equal to something. At x equal to something and at x equal to something like this. So in three ways, the values will be given. One is y dash. The second form is y dash, y dash. Third form is y only. Here, depending on these values, we have the name of the values. Suppose y and y dash are given at same values of x. Y dash are given at same value of x1, x equal to x1. Then these values are called initial values or initial conditions only. These are the initial conditions only. Both y and y dash are given at same value of x. Then these values are, or these conditions are called initial conditions only. Suppose y dash are given at different values of x, at x equal to x1, at x equal to x2 only. Then these values are called, or these conditions are called boundary conditions only. So depending on the value of x, we have the two types of conditions. Y dash are given at same value of x, initial conditions. Y dash are given at different values of x, then boundary conditions. That is different positions, same position. Y dash are given at same position, then initial conditions. Y dash are given at different positions, then boundary conditions. So we have the two types of conditions. One is initial condition, other one is boundary condition. If a differential equation is given along with initial condition, that problem is called initial value problem only. If a differential equation is given along with the boundary conditions, then such a problem is called boundary value problem only. But we are in first order and first degree differential equation. For first order and first degree differential equation, we require only one condition. That is why one condition is always initial condition. When more than one conditions are given, that may be at the same value or different values of x. That is why for first order, only one condition is required. That is why the first order with the condition is always initial value problem. Only from second order differential equation onwards, the differential equation may be either initial value problem or boundary value problem. According to our syllabus, we have both initial and boundary value problems. We'll discuss about that in next part, second higher order differential equations on. Right now we are considering only first order, first degree differential equations. Now I read the definition of initial value problem. A differential equation together with the initial condition a differential equation together with the initial condition is called an initial value problem. Initial value problem. In short form, we write this as I dot V dot P, initial value problem. Note point 1. The general form of an initial value problem for first order and first degree differential equation is dy by dx equal to f of x comma y with y of x naught equal to y naught. It is a general form of the first order first degree initial value problem. That is differential equation along with initial condition. Note point 2. Y of x naught equal to y naught is also same as, or if and only if, y equal to y naught at x equal to x naught. Y of x naught equal to y naught means y naught is the value of y at a value of x equal to x naught. So in the first order first degree, we have written the general form of the first order first degree and initial value problem definition. After this note point, we continue this 1 to 3rd bit. Don't take screenshot. The PDF file will be uploaded later. So let us go to the next page. Third bit. Methods of finding the general solution of dy by dx equal to f of x comma y. Now, here we'll discuss about the methods of finding the general solution of first order and first degree differential equation only. Let me write all the available methods of finding the solution of the equation. Later we'll discuss one by one separately on. Now I am writing all the names of the methods. The first method is variable separable method. In short form, v dot s dot m. The second method is homogeneous method, h dot m. Third one is exact method, e dot m. The fourth one is non-exact method, the fifth one is linear method. Sixth one is non-linear method. These are the methods. I will discuss about these methods, 6 methods for finding the solution of differential equation dy by dx equal to f of x comma y. Before going to one by one method, we'll discuss about something about this. In general, all the mathematical methods are divided into two parts. The first part or first type is analytical methods. Analytical methods. Other one is approximate methods. Approximate methods. Again, the approximate methods are two types: numerical methods, series solution methods. Numerical methods and series solution methods. In general, all the mathematical methods are two types. One is analytical methods, other one is approximate methods. Again, the approximate methods are two types: numerical methods, series solution methods. If any method gives actual solution of a problem, that problem may be anything. The problem may be linear equation, non-linear equation, differential equation, algebraic equation, or collection of differential equations, system of linear equation, any one. If any method gives actual solution of a problem or complete solution of a problem, then such a method is called analytical method only. If any method gives actual solution or complete solution of a problem, then such a method is called analytical method only. Whenever analytical method is not available, in such case, we go to the approximate methods only. We have very few analytical methods only till now for the problems. So the method is available, we can find the solution by analytical method. Not available, then we go to the approximate methods only. In the approximate methods, we have other methods: numerical methods, series solution methods only. The name itself, approximate, means approximate value only. The analytical methods will give actual solution, complete solution. The method is not available, then we go to numerical methods. Numerical methods will give numerical approximate value, numerical approximate solution only, just approximate solution, not actual solution, or then not complete solution only. Now, in this differential equation topic, we are going to discuss about the analytical methods only analytical methods. So because of the analytical methods, in the examination, the question itself, the name of the method will not be given. Whenever you find a question from the differential equation topic in the examination, there won't be name of the method. The problem will be given like this. The solution of a differential equation is option A, B, C, D. Or the solution of the differential equation satisfying the condition is. The solution of a differential equation satisfying the conditions is. Like this, the problem will be given. They never mention the name of the method. That is like this. The solution of a differential equation by variable sub-variable method is. Like this question will not be given. They never mention the name of the method. Depending on the problem or by looking the problem, you will be able to identify. You will be able to identify the method on. I'll give that guarantee on. Don't worry about all these 6 methods. For every method, there is some condition. That condition satisfies, we apply the particular method only. Name of the method is not given in the examination, but depending on the problem, we can identify the method and we can solve the problem. Right? Don't worry about all the 6 methods. And remember one point here. To find the solution of dy by dx equal to f of x comma y, actually there are 7 analytical methods. To find its general solution of the first order first degree, there are actually 7 methods, 7 analytical methods. But here I wrote only 6 methods only. So another method is non-homogeneous method only. Other method is non-homogeneous method. That is a descriptive method. So we are not going to discuss the descriptive method. That is why here I wrote only 6 methods: variable, separable, homogeneous, exact, non-exact, linear, non-linear. That's all. We are not going to discuss about that non-homogeneous, only these methods. Out of these six methods, only three methods are very, 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 very important. That is first, third, fifth. First, third, fifth. Out of these three important, very first one is very, 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 very important. Because if you observe all the 28 years questions, 90%, not 90%, 95% questions from variable separable only. 95% get questions on first order, first degree from variable separable only. That is a variable separable is very, 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 very important. In the recent examination also, one question was given on variable separable only for EC and also for instrumentation. Both are 2 marks on simple questions and 2 mark. So out of these 6 methods, 3 are important. Out of 3, very first one is very, 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 very important. 95% questions from variable separable on first order, first degree on. That is this method is very, very, very important and very, very, very simple also. Right? Now we'll discuss one by one separately only. Because for every method, there is some condition. If you know that condition, we can apply the particular method only. Let us move on to the next page. Now we start with the first method, method 1. The name of the method is variable separable method. Let me write the condition of the method first. Condition of the method. If f of x comma y equal to h of x into g of y, or h of x by g of y, or g of y by h of x, or 1 by h of x into g of y in a differential equation dy by dx equal to f of x comma y. Then the variables are said to be separable. This is a condition. dy by dx equal to f of x comma y. It is one of the general form of the first order first degree differential equation. In this first order first degree differential equation, f is a function of x and y. In this function of x and y, if you are able to write the function of x into function of y separately, then we can say variables are separable. This condition satisfies, then we solve the problem by variable separable method only. This condition satisfies, then we can solve the problem by variable separable method. It is a condition. For example, here f of x comma y equal to e power x square plus y square. So in the differential equation, so the function is like this, e power x square plus y square. Now tell me, is it separable or not? It is in the form of, this is the exponential function. This function is in the form of e power a plus b. Because of e power a plus b, we can separate only. We write this as e power x square into e power y square. It is purely function of x. It is purely function of y. Function of x into function of y. This is in the form of h of x into g of y. So like this, the variables are separable. We can solve the problem by the different. We can solve the problem by variable separable method only. The variables are separable. We can solve this problem by variable separable method only. Other way, the function is like this. Let us suppose f of x comma y equal to e power x divided by y. Now, tell me whether it is separable or not. Can you write the e power x by y? Can you separate this? No, we cannot separate only like about function. This is not equal to h of x into g of y. We cannot separate. So in the differential equation, the function is like this. We cannot solve this problem by differential. We cannot solve this by like this. But it is directly not separable, but indirectly separable. We can take the x by y equal to some other variable. If we take the x by y with some other variable z, then the function will be in the form of e power z. Indirectly, it is separable. So here, this function is written as function of x into function of y directly only. Here, this function is not written in the form of function of x into function of y directly, but indirectly written only. So directly separable, indirectly separable, we can solve the problem by this method only two ways. Next, we have the general solution. General solution. Till now, we have seen the condition of the method only. Next, we will see the method how to find the solution by this variables or method. Let dy by dx equal to let dy by dx equal to f of x comma y. So this 1 be the given differential equation such that f of x comma y equal to f of x comma y equal to h of x into g of y. So we are, let us suppose the given differential equation is like this. dy by dx equal to f of x comma y in such a that f of x comma y equal to h of x into g of y. That is, we are given that separable only. Then replace f of x comma y with function of x into function of y. dy by dx equal to h of x into g of y. When variables are separable like this, we write the all terms with x on one side, all terms with y on other side only. That is function of x dx on one side, function of y dy on other side. Just rearrange the terms on. We bring the g of y to left hand side. We shift dx to other side. 1 by g of y dy equal to h of x into dx like this. That is, we are writing all x on one side, all y's on one side. After this, take the integration of both sides. Integral of 1 by g of y dy equal to integral of h of x dx plus c, integral constant. So this 2 on it. Here 2 gives the required general solution of a differential equation. This equation 2 gives the general solution of a differential equation when it is integrable or not. That is, if you are able to integrate this function 1 by g of y with respect to y. When you are able to integrate h of x with respect to x, then only we can write the general solution. That is why to write the general solution of differential equation, we require the integral formula. Indirectly, we require the derivative formula also. If we do not remember these formula, we cannot write the solution. Suppose if we know the formula, we write the solution. If we do not know the formula, we stop here. If we stop here, no marks for this. So all the derivative and integral formula are important. It is a method of finding a solution. So according to this method, first you have to check whether the function is in separable form or not. Separable form, then separate and take the integration, that will give the solution. Let us go to the next page. Note point. If dy by dx equal to f of ax plus by plus c, where f of ax plus by plus c is a function of linear expression ax plus by plus c, then the differential equation can be reduced to variable separable form by substitution ax plus by plus c equal to z. That is, whenever the function is not separable directly, then we check the function is in the form of function of linear expression or not. The function is function of linear expression in this form, then also we can solve the problem by same variable separable method by reducing it into separable form. To reduce this into separable form, we replace this ax plus by plus c with some other variable z, so that we get single variable function and we solve it by variable separable. This is about method. Now next, let us consider the problems on this. We solve the problems. While solving the problems, we take the previous gate solutions also, previous gate questions also. Now I am writing the first problem on this. The general solution or in short form G dot S of dy by dx equal to under root of x square plus y square plus 1 plus x square y square is, I'm not writing the options. It is a given problem. Here we are asked to find the general solution of the differential equation. Like this question will be given, and the question itself, the name of the method is not given, just it is asked to find the solution, that is general solution of a differential equation. That's a known method is mentioned only. Method is not mentioned here. Depending on the problem, you have to identify the method for finding the solution. The given differential equation is in the form of like this. dy by dx equal to f of x comma y. The given differential equation is in the form of dy by dx equal to f of x comma y. That is a derivative form. For first order first degree, we had two general forms. One is m dx plus n dy equal to 0. Other form is dy by dx equal to f of x comma y. But the given differential equation in the question is in the form of like this: dy by dx equal to f of x comma y. In this equation, in place of this function, we check the variables are separable or not. The variables are separable, we can solve it by variable separable method. If we are unable to separate the variables, then we check the note point one form only. Directly separable, we can solve it by variable sum method. Not separable, we check this equation is like this or not. dy by dx equal to f of ax plus by plus c or not. That is, check this function is a function of linear expression or not. Now tell me this separable or not. On right hand side, the function is like this: x square plus y square plus 1 plus x square y square. Can you separate the variables or not? Yes, some are saying that separable, and some are saying no. S is correct because separable. Just look at this function. In first term x square is present, second term y square is present, and the third term 1 is present, last term both product x square into y square. If you write the first and third, 1 plus x square together at one place, and if you write the second, third, the second and last together at one place, that is x square plus 1 together at one place plus other two terms together at one place. From other two terms, y square is common, y square into 1 plus x square. So again, 1 plus x square is common, 1 plus x square into 1 plus y square. So under root, the variables are separable. So we can solve it by variable separable method. Let us solve this problem. Given in the solution, first let the given equation, given dy by dx equal to under root of x square plus y square plus 1 plus x square into y square. So this is 1. dy by dx equal to under root of, I'm writing the first and third together at one place. I'm writing the second and last together into one place, which implies dy by dx equal to under root of x square plus 1 plus y square into 1 plus x square and 1 plus x square is common, under root of 1 plus x square into 1 plus y square. Again, we write this as dy by dx equal to root of 1 plus x square into under root of 1 plus y square. So variables are separable. This is purely function of x. It is purely function of y. Variables are separable. After separating the variables, already all x on one side, all y's on one side. So bring the root of 1 plus y square this side. One by under root of 1 plus y square dy equal to under root of 1 plus x square into dx. And then write the solution, which implies 1 by under root of 1 plus y square dy equal to root of 1 plus x square dx plus c. This gives the solution when it is known. That is, if you know the integral of this function, we can have a solution. Now tell me what is the integral of 1 by under root of 1 plus y square on. Therefore, now tell me the answer for this one. Shall I write solution? Okay. Write the solution of this. Integral of 1 by under root of 1 plus x square dx means sine hyperbolic function. That is inverse. Sine h inverse of y equal to. Right hand side, it is in the form of under root of a square plus x square form. Under root of a square plus x square form. Left hand side 1 by under root of a square plus x square. Right hand side under root of a square plus x square. So x by 2 into under root of 1 plus x square plus a square by 2. That is 1 square by 2 into sine h inverse of x by 1 plus c. Or instead of sine h inverse, we can add the log of x plus under root of a square plus x square. That is 1 plus x square. It is a general solution of equation 1. So first we check the variables are separable and separable. We can solve the problem by variable solve method. Right? So for this differential equation, we require the two formulae. One is integral of under root of a square plus x square dx formula, and the other one is 1 by integral of 1 by under root of a square plus x square dx. We require these two formulae. Let us go to the next page. Next question is, second problem. The solution of dy by dx equal to 4x plus y plus 1 whole square is. This is the second problem. It is a 2 marks gate question of EC branch. It is a 2 marks gate question of EC branch. The options were given, but I am not writing the options here. Again, the differential equation is in the form of one of the general form, dy by dx equal to f of x comma y. Dy by dx equal to f of x comma y. But if you observe the function, f of x comma y equal to 4x plus y plus 1 whole square. This is not in separable form. We cannot separate the variables here. We cannot separate the variables. If you are unable to separate the variables, like first problem, then observe this function and check this function is in the form of linear expression or not. That is, the function is in the form of like this or not, f of ax plus by plus c. So just within the brackets, observe the function. This function is in the form of ax plus by plus c. That is why the given function is in the form of function of linear expression. Indirectly, it is separable. So we can solve this by variable separable method also. Like note point 1 before the first problem. Now I'm doing the problem. First, we have the given equation dy by dx equal to 4x plus y plus 1 whole square. So this 1. Directly not separable, but indirectly separable because it will be reduced to variable separable form by taking this some variable z in place of 4x plus y plus 1. Let 4x plus y plus 1 equal to z. So this 2. So we are introducing some new variable z. We are introducing some new variable z. Because of the first order, first degree differential equation, or because of the ordinary differential equation, the differential equation should contain only 2 variables, one independent, one dependent. Whenever we introduce some new variable z, then we'll get one more new variable. So this equation will contain 3 variables, but it should not contain 3. It should contain only 2. To maintain 2 variables, I have to change dy by dx in the differential equation. Whenever we introduce some new variable like this, again we have to change the dy by dx. For this, differentiate equation 2 with respect to x. Differentiate 2 with respect to x. 4x derivative is 4 plus y derivative with respect to x is dy by dx plus 1 derivative 0 dz by dx, which implies dy by dx equal to dz by dx minus 4. So this 3. If we substitute 2 and 3 in 1, then equation 1 will be reduced to variable separable format. Using 2 and 3, 1 becomes, in place of dy by dx, we are the dz by dx minus 4 equal to. On right hand side, in place of 4x plus y plus 1, we are the z. square. If we shift the -4 other side, the equation becomes dz by dx equal to 4 plus z square. And observe the right hand side. Left hand side only derivative is present. On right hand side we have a function. That too it is only function of z variable. Function of z variable only into 1. So variables are separable on right hand side. We can separate variables. Which implies bring the 4 plus z square this side, that is to left side, from right hand side to left hand side, and take the integration. Integral of 1 by 4 plus z square dz equal to integral of 1 dx plus c. Now integrate. This integral gives the solution. Just like previous problem, this integral gives a solution when you integrate this one. On left hand side, the function is in the form of 1 by a square plus x square form. Integral of 1 by a square plus x square. Integral of 1 by a square plus x square dx equal to, we require this formula. That is 1 by a into tan inverse of x by a, which implies 1 by 2 into 4 means 2 square. 1 by 2 into tan inverse of z by 2 equal to right hand side x plus c. It is a solution, general solution, but the solution is in terms of new variable z and old variable x only. Our final solution will be in terms of two old variables x and y only. So replace z with our assumption 4x plus y plus 1 only. But z equal to 4x plus y plus 1. Therefore, 1 by 2 into tan inverse of 4x plus y plus 1 by 2 equal to x plus c is a general solution of 1. So indirectly separable here only. It is a 2 marks gate question only. Easy 2 marks gate question. Next, we try to do 2 more problems. But here, now the session is 4 o'clock. Timing is. Our class is up to 4 o'clock only. So we stop here. We close the session here. Now, after this, we have a break. If anyone has a doubt, then we can ask the doubts now. 4 to 4:30, I will take the doubt session class. With this problem, today I will close the session. Tomorrow we continue this topic only. Now take the break up to next class. And 4 to 4:30, I am taking the doubt session. Now you can ask the question. Hello.
Sir, actually, I wanted to know what. Hello.
Hello. Tell me.
Sir, I wanted to know what is the importance of, means I am not able to understand why, what is that, or the difference here, sir, means dy and dx. Do they have any significance independently? Because in derivative, we take the differential with respect to, means the independent one.
You want the difference between the just dy and dy by dx, right?
Yes, sir. Yes, sir. Yes,
Suppose
sir.
if you want to find the change in one quantity correspond to change in other quantity, in such case we write the change as dy by dx. Suppose if you take a
Yes, sir.
area of circle, what is the area of the circle formula?
Yes, sir.
The radius changes, then area will change.
Pi r square.
Pi r square, right? So the radius changes, area will change only. That is one quantity. Area quantity is depending on the radius quantity. So mathematically we write this as y equal to f of x. Here x is the radius and y is the area only. Y depends on x. So if you want to write the change in one quantity with respect to other quantity, we write the dy by dx only. Suppose if you want to find the change in only one quantity, then we write the dy. If you want to write the change in only one quantity x, we write the dx. While finding the errors, we can write the only change in one quantity only.
And sir.
Tell me.
Okay, sir. Okay.
Okay.
Sir, can there be an equation where both partial derivative and ordinary with each other?
No. Only either purely ordinary or partial. But you can find like the both ordinary and partial in some cases partial differential equation. Even though that partial derivative, we can write that as ordinary derivative when it is a function of only one variable. We do that problem also in partial different derivatives equation.
Oh, yes.
Okay. But generally, in general, we cannot find both at one place.
And sir, last doubt. But we can indirectly say that the partial derivative which depends upon only one independent functions, we can tell that it is a ordinary differential equation.
Even though the function is a function of more than one variable, only one quantity depends on one quantity, then we can write that partial also as ordinary only. Hello?
Okay, sir. Will the solutions will be different or it will be same, sir?
Different. Here for ordinary differential equation, solution is a
will be different.
Function of one independent variable. Their function of more than one variable. Hello?
Okay, sir. Okay, sir. And last doubt, sir. Can we take a dependent variable with respect to another dependent variable?
No. We cannot write. We'll write only the derivative of dependent variable with respect to independent variables.
Only independent variable.
That is possible, sir, whenever it is a chain rule.
That's all. Thank you.
Chain rule case we can write only. Chain rule case only. One depends on other one. Hello?
We can take, sir, with respect to. Hello, sir. We can take with respect to another dependent variable.
Chain rule case only. One function depends on other function. Again, inner function depends on other function. In that case, chain rule we write on. Not here. In the differential equation, we always write the derivative.
Okay, sir.
Okay.
Okay, sir. Okay, thank you, sir.
Right. Hello. Hello,
sir. Am I audible?
Yeah, audible. You can ask.
Sir, I have a doubt regarding the degree of the differential equation.
Okay, you can ask.
Sir, you have told that the power shouldn't be any fraction or
rational or surd.
Sir. You said that regarding if we have d square y by dx square whole power 3 plus dy by dx whole power 3 by 2.
Okay.
Can we say the degree is 1?
No. Actually, suppose the equation is dy by dx power 3 plus d square y by dx square power 3 by 2 equal to, let us suppose, some variable.
Okay, sir.
Okay. We can shift the dy by dx other side.
Okay, sir.
Uh,
Sir, if we have, uh, if we cannot change that fraction into an integer,
we cannot write degree only.
can sir d square y by dx square whole power 1 plus
Wait.
dy
Let
by
me,
dx whole power 3 by 2, sir.
let me write. If you tell, I write on paper. Wait.
Okay, sir. Okay.
Tell me. Will you tell me the equation? Hello?
D square y by dx square whole power 1
Whole power. What is the whole power? Hello? Am I audible? Hello?
hello
Tell me.
d square y by dx square whole power 1
Okay.
plus
Hmm.
dy by dx whole power 3 by 2
Okay. Next.
plus
Okay.
y plus x equals to 0.
Okay, right. Now in this case, for second order
Sir, your
derivative,
voice is not audible.
for second order derivative, power is 1. For first order derivative, power is
No,
fraction.
sir, your voice is not audible.
Not audible? Now? Is it audible? Hello?
It's breaking, sir.
Breaking. Is it audible? Is it audible?
Is audible, sir.
Is it audible?
Hel-
My voice is audible or not?
Hello, sir.
Hello? Audible or not?
It is audible, sir.
Audible. So if you write the dy by dx power 3 by 2 on left hand side, and if we shift all other terms other side, minus x minus y minus d square y by dx square. After this, we can eliminate this fraction. So here the fraction is 3 by
Sir,
2.
could you please write it on the screen, sir?
Screen. Okay. I'm writing here on the screen. D square y by dx square power 1 plus dy by dx power 3 by 2 plus y plus x equal to 0. It is your equation. For second order derivative, power is 1. For first order, power is 3 by 2. Because of this fraction, directly we cannot tell the degree of the differential equation. If it is possible to eliminate this fraction, we eliminate only, so that we can add the degree. But here possible. Except this term, we shift all of that to other side. Dy by dx power 3 by 2 equal to minus x minus y minus d square y by dx square. The fraction general form is p by q only. Our aim is eliminating only 1 by q, not p by q only. So to eliminate 1 by q, we take the power both sides q. Like that here, our aim is eliminating only 1 by 2, not 3 by 2 only. So to eliminate 1 by 2, take the square on both sides only. Dy by dx 3 by 2 whole power 2 equal to minus x minus y minus d square y by dx square power 2 only. These two get cancelled. On left hand side power will be 3, right hand side power will be 2. So degree will be 2 only. Because if we expand this just like a plus b plus c whole power 2, then the highest derivative power will be 2 only. So degree will be here 2 and order will be 2 only. Is it okay? Hello?
Sir, okay. I am asked that if the least derivative power is fraction
Okay.
and we couldn't make it as integer,
No,
can
no, no,
we
no.
say that
No. All powers.
can we
are
say
the-
the degree according to the highest derivative in that equation?
In the definition itself, I told that the highest integral power of the highest order derivative occurring in the differential equation when it is free from fractions and fractions and radicals. That is not only for the highest order derivative, that throughout the equation, the powers of the derivative should not be powers. Should not be powers like this, fraction and radicals on. After eliminating the powers of all other, only we can write on. That in other way, simple way, the differential equation should be in the form of polynomial. That's all. A0 plus a1 into x plus a2 into x square plus and so on plus an into x power. It is a general form of the polynomial. It is a polynomial in variable x. Like that, the differential equation should be in the form of polynomial in terms of derivative only, sir, of any order. I think your doubt is clear. Hello? That is clear? Hello? 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 Is it understood? Are you getting? Hello? So to write the degree of the differential equation should be in the form of polynomial in terms of derivatives, so that we can write down. Hello? Hello? Tell me.
Hello, sir.
Tell me.
Yeah, I wanted to know for the transcendental differential equation, like sin y equal to sine of d square y by dx square. What is the degree of that equation?
Wait. I'll write down. Tell me.
Y equal to sine of
Y equal to sine of
d square y by dx square, or
d square y by dx square, right?
Yeah.
On other side, we have the transcendental function. Directly, we cannot write the degree.
Okay.
So the degree of the equation depends on the highest power of the highest order derivative.
Yes.
This derivative is not present independently only. The derivative is present as a function of this.
Yes, sir.
If we can remove the sign of this, then we can write the degree only. To remove the sign, I am bringing the sign this side only. That becomes sine inverse of y equal to d square y by dx square.
Okay.
So on right hand side, we can write the degree because it is a sine inverse of y.
Degree is 1.
Degree is 1, order is 2.
Oh, sir, and if we like expand the sign like x minus x cubed by 3, then we can't do that.
No.
Can you do that?
If you want to expand sine of d square y by dx square, we can get the infinitely many terms only.
Yes.
Whenever you have a
So
infinite,
degree is defined or undefined?
here, this equation or for a,
This one.
for this one degree is defined.
Okay. Yes, sir.
Because left hand side, no problem, doesn't matter. That is free from
Okay.
derivatives only.
Okay. Yes.
Suppose left hand side
Thank
also,
you.
if we have like this, y power dy by dx
Okay.
like this, no, we cannot write.
Oh, okay. Yes, sir. Thank you.
Hello?
Hello, sir.
Hello?
Hello. Sir, am I audible?
Audible. You can ask.
Sir, my doubt is also same. But my doubt is, if in the place of y, if x plus y is there, still degree is defined for
In place of
y. I mean, x plus y equal to sine of d square y by dx square.
repeat, x plus y equal to
Sine of d square y by dx square.
sine of d square y by dx square. Also degree is possible here. And if you bring the sine this side, then sine inverse of x plus y equal to d square y by dx square. Right?
Yes, sir. Possible, sir.
Possible here.
And if dy by dx equal to sine of d square y by dx square, then
dy by dx equal to sine of d square y by dx square. Not possible here. If we expand sine function this side, we get infinite value. Or if you bring the sine this side also again sine inverse of dy by dx. So the differential equation should not contain infinitely many terms with the derivatives only.
So here in this case, why degree is not defined, because degree is only for the highest order derivative, right?
Right. But we should have finite number of derivatives terms only. That is the condition.
Okay.
Otherwise, the differential equation should be in the form of polynomial in terms of derivatives. So polynomial itself, number of terms should be finite term.
Okay. So we should not try to expand the derivatives. If if it's leading to infinite terms, then we should say that it is that the degree is not defined.
Yeah.
Okay, sir. Thank you.
Right. Hello.
Hello, good evening, sir.
Good evening. Tell me.
Sir, I have doubt in yesterday's class, sir.
Yeah, you can ask.
Sir, yesterday lastly we have solved some 4 problems, sir, on non-linear.
Yeah.
Can you open that page, sir?
Right now, I am not in a position to open that page, but you can ask that.
Okay, sir. So there in 4th problem,
you can
if dependent variable u is multiplied with some other constant like dou square is z by dou x dou y.
u is multiplied with dou z by
dou square z by dou x dou y.
Yeah. That is a non-linear term.
But it is not here multiplied with dependent variable, sir. Then how it will be non-linear?
No. Dou square z by dou x dou y into u is there, or?
Yes, sir. U is there.
U is the dependent variable, no?
Okay. Like we need to consider dependent variable here.
All the conditions are depending on dependent variable and its derivatives.
Okay, sir. Got it, sir.
Throughout that equation is u is a dependent variable or not?
Yes, sir.
Yeah. That is why it is a non-linear.
Okay, sir. And today, after solution of differential equation, you have explained types of solutions of differential equation.
Yeah.
There some theory point you have explained, sir. Is that necessary to remember, sir? Like what is the purpose of that, sir?
Which point?
In types of solutions of a differential equation.
General solution, other one is particular solution.
Yes, sir. What are those actually used for?
No, geometrically the solution is a set of curves.
Okay, sir.
Set of curves only. Right? And for particular value, particular solution means a particular curve.
No, sir. When we will use general and when we will use particular, sir?
No, first we write general directly, general solution only.
Okay.
The condition is given, then we write the particular solution, means a particular value of x only.
Okay. Like in general solution, they will not give condition, sir.
No, they won't. If the condition is not given, we stop with the general solution only. Because without
Okay.
condition, we cannot go further only.
Okay. Okay, sir.
But
Like
general
you have solved examples, those are general.
general only. Even the condition is not given. Condition is not given. It is asked to find the solution. Means it. The problem itself, that is general solution.
Okay. Okay, sir.
Right.
Okay. Thank you, sir.
Right. Hello.
Hello.
You can ask.
Good evening, sir.
Good evening. Tell me.
Sir, I have one question in degree and order. It is d cube y by dx cube.
I will write. Let me. Tell me.
D cube y
y by dx cube
plus
plus.
d square y by dx square.
Okay.
It is whole square of this term, second term.
For second term, whole square.
Yes, sir. Plus 5
Okay.
cos bracket dy by dx
Okay.
plus 6y
Plus
equal
6y
to 0.
equal to 0.
Sir, what is the sir order and degree? We can find or
Here order is possible 2. We cannot write degree directly.
but sir, in the last problem you told dy by dx is equal to sine of d square y by, because
Yeah.
infinite term is also possible in this.
Y equal to sine of dy by dx or any order, that doesn't matter. If we bring this sign this side, we get the sine inverse of y.
No,
Sine
no,
inverse
sir.
of y is free from derivatives only.
Not this problem, sir. One more problem you told, na dy by dx is equal to
Dy by dx equal to
sine d square y by dx square.
sine of d square y by dx square. Here
Yes,
it is
sir.
not possible.
Yes, sir. So why in this is possible order?
Order is possible for any equation.
Okay, sir.
Order is possible for every equation. Only degree is not possible.
Okay, so sir, in above equation, my equation also is degree
Degree is not possible. If you bring the first, second, last term other side, and if we shift the cos other side, then cos inverse of that sum of the derivatives only. So first of all, to write the degree, the differential equation should be in the form of polynomial. Polynomial means number of terms should be finite.
Okay.
If we have a finite number of derivatives in the differential equation, then only degree will be possible only.
Okay, sir. But yeah, order is possible, sir. Yes.
Order is always possible.
Okay. Actually, I thought here derivative, second derivative is like third derivative is highest, so power, degree will be one. In this way, I thought.
No, not like that, not like that.
Okay. Thank you, sir.
Right. Hello?
Hello, sir.
Hello? Tell me.
Sir, my internet connection was weak. That's why I couldn't hear before.
Okay. Now you can ask.
Sir, I will say two equations. Please tell me the degree of that.
Okay. Right. Tell me. Right.
D square y by dx square plus
D square y by dx square plus
dy by dx whole power 3 by 2
dy by dx whole power 3 by 2
plus sin y equals to 0.
sin y equal to 0. Okay.
Sir, for this the degree is 2, sir. Am I correct?
First you have to shift the other to other side. And we check whether it is possible or not. We check it out. Dy by dx power 3 by 2 equal to minus sin y minus d square y by dx square. On left hand side we have a power fraction 3 by 2 only. Right hand side no fraction only. But our aim is eliminating only 1 by 2, not 3 by 2 only. So to eliminate 1 by 2, we take whole power on both sides only. Then these two get cancelled. Now degree will be possible here.
Sir, another one is
Is it okay?
okay, sir. Degree is 2.
Degree is 2. Because our right side is a minus b, a plus b whole square form.
Okay, sir. D square y by dx square whole power 5 by 4
d square y by dx square whole power 4.
5 by 4, sir.
5 by 4. Okay. 5 by 4.
Plus dy by dx whole power 3 by 8.
Hmm.
Plus sin y equals to 0.
Sin y equal to 0.
3 by 8, sir.
3 by?
8. dy by dx whole power
Okay.
3 by 8.
Right, right.
Sir, for this degree is not possible. Am I correct, sir?
Yeah, yeah. Because we cannot
Correct, sir.
eliminate already.
Sir, can I say that if the any sign of dy by dx, that means any trigonometric function of derivative, we cannot find the degree.
No, no, no. We cannot say. That depends on the equation. Suppose the equation is like this: y equal to sine of d square y by dx square. Here we cannot say that degree is not possible. Degree is possible here. If you bring the sine this side, then we get the sine inverse of y equal to d square y by dx square only.
Okay, sir. Okay.
So
Sir,
left
you
hand
have
side is-
told that in initial value point, you have told that boundary conditions.
Yeah.
Will you say it again, sir?
That is possible. Boundary conditions are possible only from second order onwards. So if it is second order equation, we require the two values. Because to find the C1, C2, two unknowns, we require two equations. For getting
Okay,
two
sir.
equation, conditions will be given like this. Y equal to something, y dash equal to something. X equal to something, x equal to something. Or y dash, or y, y. In three ways, the conditions will be given. Suppose y, y dash are given at same value of x. Let us suppose x1, x1. At the same position x1, y is given, y dash are given. Then these conditions are called initial conditions. Okay. Next, at different positions at x1, at x2, y, y dash are given like this. Then boundary conditions on.
So how we are saying that they are initial conditions, sir?
At same position, at different positions on. Initial, starting, initial. That initial is, suppose if you take a boundary condition, initial, what is the initial here? X1. Other one is boundary, far away to this one. At different positions, different ends, at different ends of any.
Sir, in boundary conditions, only x1 to between x1 and x2 only possible, no, sir, the values.
At two different positions, X1, X2. A simple way, if you want to remove like this, at different positions or same position given like this.
Sir, other than x1 and x2, the values are possible, sir.
Not possible. Only two positions only. At two positions we can choose. Or at
Here
same position.
only at x1 we can choose.
Y dash will be chosen at the same position or different position. Suppose both are y dash, only same position. Both are y's and only at same position. We cannot choose at different positions.
Okay, sir. Thank you, sir.
Sorry. So wait. Here both y's are given. Only y's are given at different positions only, not same position. Both y dash are given at different positions only, not same position. Only y dash means at the same or different position. Is it clear?
Okay. If y dash and y dash are given at same point
should be
also, we
boundary
should not take that as an initial condition, sir.
No. So definitely boundary.
Only y and y dash are given at same point, we should take that as an initial.
Right.
Thank you, sir. Thank you so much.
Hello, sir.
Hello. Tell me.
Sir, I was having one more doubt, sir. Sir, in that page only, sir, whatever you have solved.
Oh, right now.
Yes, sir.
Tell me. Doubt.
Sir, previous page.
Previous page. And you asked me that one?
No, sir. That only, sir. Recently, you have explained one problem. Like just now, you have explained one problem, right, sir? For some.
Yeah, I raised it just now. I raised it.
You raised, sir. Sir,
Can
there.
I say it again, sir?
Yes.
Second equation or first equation?
First one.
D square y by dx square plus dy by dx whole power 3 by 2
Okay.
plus sin y equals to 0, sir.
This
No, not this one. At 3 by 8 something.
3 by 8 and 5
Yes,
by 4, right?
yes, sir. Yes, sir.
Yeah, sir.
Sir, here, if why degree we can't define, sir? Because if we send that dy by dx that side,
Ah.
and we will multiply power 8, sir, on both sides.
Now, if I write like this, the power like this, the equation will be like this: dy by dx power 3 by 8 equal to sin y minus d square y by dx square power y 5 by 4. We cannot eliminate only. Other side will be sin y minus dy by d square y by d square 5 by 4.
Sir, actually, we will take order of the highest degree, right, sir?
But condition is, in the differential equation, every power of the derivative should be positive integer only.
Yes, sir. Actually, first equation is d square y by dx square, sir. You send that dy by dx and sin y that side, sir.
Okay, right.
And I will multiply power. Power I will multiply by 2, 8 on both sides.
Right, no problem.
Then I will get integer value only, right, sir?
That this side okay, but other side we have other one.
But that you are not considering, sir. Only for highest degree we are considering. No?
Oh, one more condition is for every derivative the power should be positive integer. That is
okay, for every derivative. Okay, okay, sir.
Or other way, the condition is derivatives present, the number of derivatives should be finite only.
Okay, okay. Okay.
And the power should be positive integer. That is the condition. Or other way, in simple way, we can say that degree is possible whenever the differential equation is in the form of polynomial.
Okay. Okay, sir. Thank you.
Polynomial in x means in place of x we have derivatives.
Derivatives. Okay.
Okay.
Okay, sir.
Hello? Hello?
Hello? No doubt.
Hello?
No doubt, sir. No doubt.
No doubt. Okay. Okay. Hello?
Sir, I have no doubt. Already cleared.
Clear? Okay. Next. Hello? 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 Tell me.
Sir, can we know your names?
My name,
Yes, sir.
Ravinder Reddy.
Yes, sir. Sorry,
Hello?
sir.
Ravinder Reddy.
Sir, can you tell? Okay, sir. Okay, sir. How to? Sir, can we have your number or email ID so that we can ask out if you want?
I'll give the WhatsApp number 9848 Are you writing?
Yes, sir.
9848 905004. 90.
Okay, sir. 9848905004.
Right.
Okay, sir. Okay. Thank you, sir.
Okay, good. Uday?